Good afternoon, my dear students. Today I am going to teach you about that how to calculate the derivative by general method. It is general method. How to calculate the derivative by general method. To calculate the derivative by general method, you should have to take some of the concepts related to the rules. The first one I am going to give you the concepts like as d by d, x x. So it is the respect to which we are going to find out the derivative of x. So dx by dx gives you 1. Actually in the mathematics dx by dx is equal to 1. Certainly we write 1. But how it comes 1? There is some of the rules. The rules is that I am going to define it d by d a x n. A x n. A is here coefficient, n is said to be power, and x is base, and here is x, then there should be also the x, then only you can find derivative. If here is x but here is y, you cannot find it. If here is x, if here is z, you cannot find it. If here is x, there should be also x, then this types of forms only you can get the derivative. So here this power n, this coefficient a, and that coefficient is also said to be constant terms. It is said to be constant term. So the rule is that the constant is taken out, a is taken out, and then after n is power, n is also taken out, then after n minus 1. So it is the an x n minus 1. So if you follow this rule, then you can have here dx by dx. So power is nothing, you consider 1. Constant is nothing, you consider 1. So 1x 1, according to this a means constant, so 1 is taken out, then after 1 is taken out, and x 1 minus 1. The rule is here n minus 1, so 1 minus 1, it will gives you x power 0, it means 1. So we write that dx by dx equals to 1. It means derivative of x with respect to x. How can we read this? How can we read this? So if you want to read this, then you have to read like as derivative of x with respect to x. It is said to be derivative of x with respect to x. If here is dy by dx, it means what? It means derivative of y with respect to x, So this rule only follows when there is this x and x should be same. Like as here, what is the derivative of dy by dx? The same answers. The derivative of dy by dx is dy by dx. Like as dx by dx is equal to 1, but dy by dx you cannot find it. Only you can write the derivative of dy by dx is dy by dx, because here the variable y and the respect is not going to same, therefore you write dy by dx. So it is the first rule. If you have been told to find out d t square by dx, then if you follow the same rule, 2 is taken out and 2 minus 1, then it will be wrong. Because do you know why it is wrong? It is wrong because the respect is not here t. the respect is here x, so it is not matching, so this rule cannot adopt this, therefore it is wrong. It is wrong. It is wrong. But if there is dt square by dt, here now the respect and the derivative variable is same, therefore you write here 2t, 2 minus 1, the power is taken out and 1 is subtracted from 2, so you can easily write 2t. It is your answer. So in this way you cannot do this, but here you can do this, therefore t x is different, you cannot make it. T and t is same, you can make it. Now I am going to say you that like as another question, d by d, d by d, ax plus b power n, d by dx, ax plus b power n, and here is x. Now if anybody asks you, can you find derivative in this condition, you should have to reply, no, we cannot find the derivative in this condition, because the power of the whole component, the power of whole component here is ax plus b power n, here is ax plus b power n, but here is only x, so how can we make derivative? It is impossible for us to calculate the derivative. If this question will be like as d by d ax plus b power n by dax plus b, then only you can find the derivative, like as n is taken out, ax plus b n minus 1. So always concentrate at the variable or the base, it should be same to calculate the derivative. So this is the vital concept regarding to the variables and its powers. So in this way I have given you these concepts, and in the next lecture I will continue another related to derivative. Thanks to all of you. Thank you.